Hello everyone, welcome to our statistics channel, Quality Statistics. Today we are going to discuss the kurtosis, which is a part of chapter Movement, Skewness and Kurtosis. In the previous videos, we discussed movements and skewness, and the rest part is kurtosis. Kurtosis refers to the steepness or pickedness of a frequency distribution. The degree of kurtosis of a distribution is measured relative to the pickedness of the normal curve. We know the normal curve as bell-shaped curve. In other words, measures of kurtosis tells us the extent to which a distribution is more peaked or flat topped than the normal curve. That is, kurtosis is measured on the basis of normal curve. With respect to normal curve, kurtosis actually refers to the relative pickedness of a distribution. It is measured in comparison with a bell-shaped unimodal symmetric curve known as normal curve. Unimodal means the mode is one. There exists only one mode, which is supposed to have moderate kurtosis. The kurtosis of the other distributions are measured and considered to have higher or lower value in comparison with the kurtosis of the normal curve. Now we discuss there are three different natures of kurtosis as number one leptokurtic, number two platykurtic, number three mesokurtic. If a curve is more peaked than the normal curve, it is called leptokurtic. If a curve is more flat topped than the normal curve, it is called platykurtic. The normal curve itself is known as mesokurtic. That is, all the other nature of kurtosis is being measured on the basis of mesokurtic, that is normal curve. All the three distributions are symmetrical, but their heights are different. The kurtosis is measured on the basis of moments, that is coefficient. Coefficient of kurtosis is equal to gamma 2. It is denoted by gamma 2. This sign is called gamma or G2. In some books, it is written as G2. G2 equals to beta 2 minus 3, where beta 2 equals to M4 by M2 square. M4 and M2 are the moments, fourth moment and second moment. Sometimes it is measured by gamma 2 equals to alpha 4 minus 3, where alpha 4 equals to M4 by M2 square. That is, sometimes in some books this beta, this alpha are same but expression is different. Here alpha 4 is the fourth moment in standard units. For a normal distribution, alpha 4 equals to 3 or beta 2 equals to 3 and gamma 2 equals to 0. Because gamma 2 is measured as beta 2 minus 3, that is when we put beta 2 equal to 3, then it becomes gamma 2 equals to 0. Thus, for a mesokurtic distribution, gamma 2 equals to 0 and beta 2 equals to 3. And it is the important part of whole kurtosis analysis that mesokurtic is 0, and on the basis of mesokurtic we can measure the other kurtosis nature. A positive value of gamma 2 indicates that the distribution has concentration of values near the central tendency. Central tendency implies arithmetic mean and has high tails compared to a normal distribution. With the same standard deviation, thus for a leptokurtic distribution, gamma 2 greater than 0. Gamma 2 greater than 0 means beta 2 greater than 3, because already we have gamma 2 equals to beta 2 minus 3. Similarly, a negative value of gamma 2 indicates that the distribution has low concentration of values near the central tendency and has low tails compared to a normal distribution with the same standard deviation. Thus, for a platycardic distribution, gamma 2 less than 0, that is beta 2 less than 3. In the leptocardic, we got beta 2 greater than 3, and in platycardic, we got beta 2 less than 3. Already we have discussed that all cardiac, platycardic and leptocardic are being measured with respect to mesocardic. Hence, for mesocardic, gamma 2 0, for leptocardic, gamma 2 greater than 0, and for platycardic, gamma 2 less than 0. Thus, a distribution is leptocardic if gamma 2 greater than 0, that is beta 2 greater than 3, mesocardic if gamma 2 0 and beta 2 3, and platycardic gamma 2 less than 0 and beta 2 less than 3. The figures are as follows. This is normal distribution, that is beta 2 mesocardic, this curve is mesocardic, and the flatter curve is platycardic, and this steeper curve is leptocardic. And there are 3 curves here: leptocardic, mesocardic and platycardic. On the vertical axis, we measure frequency density, and on the horizontal axis, we measure different values of x value. This is all about today for kurtosis analysis. Thank you all for watching this video.